By Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to talk about zeros of a polynomial, basically the geometrical meaning of zeros of a polynomial and the relationship between zeros and coefficients of a linear polynomial, a quadratic polynomial and a cubic polynomial. So are you guys ready? Just comment in the chat, guys. Hello Athan Pro, welcome to this session. Am I audible and visible? Are you guys able to hear and see me properly? Just comment quickly in the chat so that we can start with the class. So the relationship between zeros and coefficients of a linear polynomial, a quadratic polynomial and a cubic polynomial, that is there in your syllabus, in your CBSE syllabus. So we'll do the basic thing and then we'll be doing some questions as well on the basis of those concepts. So I hope you guys are ready. Am I audible and visible properly? Hello Karthik, welcome to this session. Hello Babuan. Long time no see, Babuan. Hello Dhananjay, good afternoon, welcome to this session. It is evening, although Dhananjay, this is a transition time, right? You can, many a times you say it evening and many a times you call it afternoon as well. So are you guys ready? Have you already started studying polynomials in grade 10? Okay, so let's start with it, guys. The very first thing over here is graphical meaning of zeros of a polynomial. So zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. That is, x is equal to a is a zero of the polynomial if p of a is equal to 0. Okay, Dhananjay. Hello Aditya, welcome to this session. So you see over here, basically if you will make the graph of a polynomial, suppose this is the x-axis, this is the y-axis, this is the origin, and you know that suppose if you have got a graph like this, so can you tell me how many zeros are there of this polynomial? Can you comment that quickly in the chat, guys? How many zeros are there of this polynomial? No problem, Yash Arora, you can also understand this, it's not a big deal. So how many zeros are there of this polynomial? Why 3, Babuan? See, the graph of this polynomial is intersecting the x-axis at 1, 2, 3 and 4 points. So you will say 4 zeros are there of this polynomial. So basically why you say that 4 zeros are there of this polynomial? Because the graph of this polynomial is intersecting the x-axis at 4 different points. And basically you know that if you take any point on the x-axis, it is of the form x comma 0 or not. You have studied this in basics of coordinate geometry. Any point on the x-axis is of the form x comma 0, correct or not? And you see, what is this 0? This thing is nothing but p of x. The value of the polynomial, if you put the value equal to x, the value of the polynomial itself is becoming equal to x, right? Equal to 0. So therefore the x coordinate of all of these 4 points, x coordinate of these 4 points, they are the zeros of this polynomial. Is it clear? Any doubt in this basic concept? It is. Why these are called the zeros? I mean, why we are saying that 4 zeros are there to this polynomial? Because any point on the x-axis is of the form x comma 0. You can say that the value of the polynomial is itself becoming equal to 0 at those points. I hope that is clear to everybody in this session. Now suppose I ask a question from you. If I've got a polynomial like this, how many zeros are there to this polynomial? Can you tell that, guys? How many zeros are there to this polynomial? Just see this figure. Class 9 and 10, Babuan, on the Infinity Learn Class 9 and 10 YouTube channel. So can you tell me how many zeros are there to this polynomial? Can you comment that quickly? Okay. So have I tricked you? I will see that. I can see only Babuan and Aditya answered it correctly. See, you just have to count those points through which the graph is passing through the x-axis. So only one point is there on the x-axis through which the graph is passing. So on this point only, suppose the value is a, suppose the value of x is a and y is becoming equal to 0. So you will say this polynomial is having only one 0. Any point on the y-axis is of the form 0 comma y. You got it? The value of y coordinate is not 0 on the y-axis. You got it? only the x coordinate is 0. So these will not be the points including 0 over here. Only one point is there which will be counted as 0. So this polynomial is having only 1 0. Is it clear to everybody in this session? Exactly. And the reason is clear to you or not? The reason must be clear. Suppose a simple question comes in your school examination or in your boards. So you have to give the reason as well. Even if it's a 1 mark question, it's not that you will say only 4 zeros are there. You have to write a statement giving the reason that why you're counting those 4 points as zeros. Is it clear to every student over here? Tell me quickly. I hope it is clear to you. Okay. Now over here, if I've got a graph, suppose I'm getting a graph over here, simple graph only I'm taking. Basically, suppose this point is, suppose 3, 0, this is 2, 0, this is 2, 0, this is 1, 0, and this is equal to minus 1, 0. Got it? I hope this is clear. So how can we write the polynomial from here? That also you have to understand. So the polynomial, suppose it is already given that the polynomial is having 4 zeros only, right? It's having 4 zeros only. So can we not write the polynomial like this? X minus 1, if I consider this thing, x minus 2, x minus 3 over here. And if it's having a 0 equal to x is equal to minus 1, so I have to take x plus 1 as well. You got it or not? So like this is one of the polynomials whose zeros are minus 1, 1, 2 and 3. This is one of the polynomials whose zeros are minus 1, 1, 2 and 3. There are infinite such polynomials whose zeros are these. You got that logic? Simple logic is, see the zeros of this polynomial, they are minus 1, 1, 2 and 3, right? Suppose I multiply by 3 over here. Then also this polynomial is going to have zeros equal to minus 1, 1, 2 and 3, yes or no? Suppose I multiply this thing by 7, then also this is having zeros equal to minus 1, 1, 2 and 3. So what does it mean? There are infinite such polynomials whose zeros are minus 1, 1, 2 and 3. Is this logic clear to everybody? I was choked for some seconds. Is this clear? So it's not that only one polynomial is there whose zeros are these. Infinite number of such polynomials are there whose zeros are minus 1, 1, 2 and 3. I hope it is clear. I hope this logic is clear to every student in the class. Simple logic it is, right? Okay. Now basically, if it is given, if 1 0 of this quadratic polynomial is this, can you find the value of k? Can you tell the answer to it quickly, guys? If 1 0 of this quadratic polynomial is 2, then can you find the value of k out of the given options? It's a simple question, but you can expect a question like this in 1 mark in your examination. Okay, so Babuan is getting 1. What about Dhananjay? What about US Beta? What about Yash, the Beast? What are you getting, guys? Can you tell the answer quickly? Aditya is getting minus 10. What about other students? So suppose the polynomial is p of x. Just name this polynomial. This is p of x, right? So it is given that 1 0 of this polynomial is 2. So what does it mean? Can I not say that p of 2 is equal to 0? Because that is the definition of 0 of a polynomial. So I can put x is equal to 2 in this polynomial. So I will get 2 square plus 3 into 2 plus k is equal to 0. Right or not? So if you solve this equation, you'll get k is equal to, this is 4, this is 6, minus 10. Very good. So minus 10 is the answer. Any doubt in this question? Exactly, Babuan. Minus 10 is the correct answer. You have done some calculation mistake over here, Babuan. Is it clear to every student in this session? Any doubt in this thing, guys? Tell me. Any doubt in this thing, guys? Simple question on the basis of the meaning of 0 of a polynomial. It is as simple as that. Now we have got a concept. Okay, one more question is there. What should be added to this polynomial so that 3 is the 0 of the resulting polynomial? Can you tell the answer? What should be added to this polynomial so that 3 is the 0 of the resulting polynomial? Can you tell that quickly, guys? Life was good when we were in 10. No, life will be good when you work hard in grade 11 as well, Rituraj. It's not like that. Don't give up so easily. Life would be much better if you work very hard in grade 11 and 12. Just have faith in me. If you work very hard in grade 11 and 12, and especially if you are a science student, that is the very foundation of your, basically your academic life, you can say. So you are getting 2 over here. What about other students? Babuan is getting 2. So it is given that what should be added to this polynomial so that 3 is the 0 of the resulting polynomial. So suppose I want to add anything y in this polynomial, right? Suppose I want to add y in this polynomial, but this polynomial is in variable x, right? This polynomial is in variable x. Now if I add y, then 3 is becoming the 0 of this polynomial. So can I say that p of 3 has to be equal to 0, guys? Yes or no? So in place of x, you have to put 3 in the polynomial. So it will be 3 square minus 5 into 3 plus 4 plus y. That is equal to 0 or not? So from here you have to find the value of y. What are you getting? Tell me. Just solve this equation easily. So this is, so y is coming out to be 2 over here. So therefore you will say y is equal to 2 is the answer. Very good, Dibis. That is correct, Aditya and Babuan. Very good. It's a very simple question. I hope it is clear to every student in this session. Now we want to study this concept, relationship between zeros and coefficients of a polynomial. It's a very simple concept. Just understand it properly. Relationship between zeros and coefficients of a polynomial, that you have to understand. There is something called Vieta's formula, right? Vieta's formulas. Normally you don't hear this name in school, but still these are known as Vieta's formulas. Okay, very simple it is, you'll understand it properly. See, when you have got a linear polynomial, that is ax plus b, the standard form of a linear polynomial is ax plus b, right? The coefficient of x cannot be equal to 0, because then this will not remain a linear polynomial. Now a linear polynomial, it has only one 0. Suppose I represent that 0 by alpha. So that 0 is equal to minus b by a. Will you agree with me? That only one 0 is there of a linear polynomial, and that 0 is equal to minus b by a. Yeah, I'll explain that, Ajit. Abscissa bata diya hai kya? ऐसा कुछ नहीं है बाबूआन. I hope it is clear. चलो, ठीक है. So linear polynomial, it has only one 0, and that is, you can represent it by alpha, and that is equal to minus b by a. Now if you have got a quadratic polynomial, okay, ax square plus bx plus c, quadratic polynomial, this is the standard form of a quadratic polynomial, where obviously a cannot be equal to 0, because if coefficient of x square becomes equal to 0, this will not remain a quadratic polynomial. So a quadratic polynomial can have maximum 2 real zeros, right? So we represent those zeros by alpha and beta. Now what is basically Vieta's formula? You'll understand it very quickly over here. So the logic is, we take one 0 at a time. In the first case, we are taking one 0 at a time and add them up. So one 0 at a time and we are adding them up. You got it? Now the logic is, sum of the zeros is minus b by a. See it patiently. Minus b by a. Got that logic? Now we will take 2 zeros at a time. 2 zeros at a time. So alpha beta will come up. Correct? So you see, it was minus b by a. Now I will change the sign to plus c by a. Got that logic? I am changing the sign to plus c by a. I hope that is clear. Now suppose I have got a cubic polynomial, a 3-degree polynomial. So that is equal to ax cube plus bx square plus cx plus d, the standard form of a cubic polynomial, where obviously a cannot be equal to 0, coefficient of x cube cannot be equal to 0. Now it will have maximum 3 real zeros, so alpha, beta and gamma. Correct? Alpha, beta and gamma. So what I will do? Again I will take one 0 at a time. So 1 0 at a time, and then I'll add them up. So alpha, beta, gamma. It will again be minus b by a only. You got it? It will again be minus b by a only. Now what I will do? I can have two zeros at a time. 2 zeros at a time. Alpha, beta, beta, gamma, alpha, gamma, and add them up. Now you see this is minus b by a. I will change the sign to plus c by a. You got that logic? Now what is left? 1 0 at a time, 2 zeros at a time. Now I will take 3 zeros at a time. So that will be alpha, beta, gamma. Correct? So you see plus c by a, change the sign to minus d by a. You got it? So that is the pattern how you remember that. Ajit, they are interchangeable only, although zeros are called for polynomials and roots are called for equations. But in many books you will see that in place of zeros they use roots as well. But to be precise, zeros are for polynomials and roots are for equations. You got that logic, Ajit? Now is the pattern clear to everybody? Vieta's formula. The pattern is clear for a linear polynomial, for a quadratic polynomial, for a cubic polynomial. Any doubt in this thing to any student in this session? The Beast, Aditya, Babuan, Ajit. Hello Ananya, welcome to this session. Kitty, is it clear to you? Okay, now there can be one more thing. See, any number of zeros can be there, na? I mean, a polynomial can be of any degree actually. Hello, Happy Sign, welcome to this session. It can be of any degree. Suppose I am explaining over here itself, although there is a crunch of space. But what I can do, wait, I'll make space for you. So you see, for linear you can remove it over here because that you already know, it's a very simple thing. Yes or no? So that is called something called Vieta's formula. Very simple logic, and if you understand it properly you can do many big questions. Now for cubic polynomial, for quadratic we have already discussed. Now what about a 4 degree, a biquadratic polynomial? Ax raised to the power 4 bx cube cx square plus dx plus e. If you have got something like this, okay, it's a 4 degree polynomial. You got it? So it will have maximum 4 real zeros or not? You got it? Okay, Kitty, I'll explain once again. It will have maximum 4 zeros over here. So the pattern will be what? 4 zeros you represent like this: alpha, beta, gamma and delta. You represent like this 4 zeros. Now the same pattern will happen over here itself. What is the first pattern? You will take 1 0 at a time. 1 0 at a time means alpha plus beta plus gamma plus delta. 1 0 at a time. You got it? Now again it will be minus b by a only. It will be minus b by a only. Now what you will do? You will take 2 zeros at a time. So alpha, beta, beta, gamma, gamma, delta, alpha, delta. You got it? So from minus b by a, change the sign to c by a. You got it? Minus b to plus c by a. Now what is the next thing? You will take 3 zeros at a time. So alpha, beta, gamma, delta, alpha, gamma, delta. You got it? And you see this is plus c by a, change the sign to minus d by a. You got it? Now it will become minus d by a. Now what is the next possibility possible? Next possibility is 4 zeros at a time. Alpha, beta, gamma, delta. So it is minus d by a, change the sign to plus e by a. Plus e by a. So that's all. I hope it is clear. In the same manner, you can find the relationship between coefficients and zeros of a polynomial of any degree. Is it clear to everybody? Don't spam Ananya. Is it clear to everybody in this session? Just confirm that in the chat. Exactly, that is coming out to be plus e by a, Happy Sign. Any doubt in this thing? Mahendra, is it clear? Oh my god. Okay, not getting, but obviously, okay, I'll explain it once again. See, it will take some seconds only, but it is very important you'll understand it properly. I'll take 1 minute only, you'll understand Ajit over here, okay? Concentrate on the board. If you have got a 2 degree polynomial, that is a quadratic polynomial, ax square plus bx plus c, a cannot be equal to 0, the coefficient of x square cannot be equal to 0, otherwise it will not remain a quadratic polynomial, you know that. So it can have maximum 2 real zeros. So what is the first pattern? First pattern is take one zero at a time and add them up. One zero at a time, add them up. It will be every time minus b by a. You got it? One zero in one time and then add them up, minus b by a. Now take two zeros at a time. Two zeros at a time, minus b by a to plus c by a. Change the sign to plus c by a. I hope that is clear. Now if you have got a 3-degree polynomial, a cubic polynomial, obviously a cannot be equal to 0. So it will have maximum 3 real zeros. The same pattern, take one zero at a time, add them up. It will be again minus b by a. Now take two zeros at a time, alpha, beta, beta, gamma, alpha, gamma. Add them up. Now you see this is minus b by a, change the sign to plus c by a. You got it? Now three zeros at a time. Three zeros at a time, change the sign to plus c by a to minus d by a. Got that logic? Now if you have got a 4-degree polynomial, over here as well a cannot be equal to 0, right? So over here as well take one zero at a time, it will be minus b by a only. Take two zeros at a time, change the sign to plus c by a. Take three zeros at a time, change the sign plus c by a to minus d by a. Now take 4 zeros at a time. So it is minus d by a, so it will become plus e by a. Is the pattern clear now? To every student in this session, don't spam please. I hope it is clear. Ananya, 360s. Happy sign, Babuan, Ajit. Everybody in this session, is it clear? Exactly, you're right, happy sign. That's it. So this is a very important relationship actually. See, obviously there is a derivation to each of these relations, but obviously I'm not doing it right now. I hope you understand that, okay? Instead of that, we will be doing questions, right? And for quadratic polynomial, I will explain as well. Okay, Babuan. For quadratic polynomial, I will explain as well how to find this relation, okay? I hope that is clear to every student over here. Now let us do some questions on the basis of these relations. If one zero of this quadratic polynomial is negative of the other, can you find the values of k? Can you try doing this one, guys? And let me know the answer in the chat. Okay, and this relation was these relations between the zeros and coefficients of different types of polynomials. They are known as Vieta's formulas. These are known as Vieta's formulas. Okay? Okay, try doing this one, guys. If one zero of this quadratic polynomial is negative of the other, you have to find the values of k. No, it is not Vieta, it is Vieta's. It is not Vieta's formula. Exactly, Vieta's. Try doing this one and let me know the answer in the chat quickly, guys. So you see, one zero is negative of the other. It means if one zero is alpha, the other zero is minus alpha or not. One zero is negative of the other. So whenever you've got something like this, you have to take sum of the zeros. In case of a quadratic polynomial, sum of the zeros is minus b by a. You got it? It is minus b by a in a quadratic polynomial. So over here, what is minus b? Minus of b over here is the coefficient of x. So that is minus 8k square minus 40k over here. And a is the coefficient of x square. A is the coefficient of x square, so that is equal to 4. So you see this will be cancelled out. Alpha plus alpha will become 0 or not. So over here, if you simplify and if you take 8 as common in the numerator, what will I get, guys? I'll get not only 8, in fact 8k can be taken as common. So you can take 8k as common over here. So what will you get? 8 minus k minus 5 divided by 4 over here. I hope it is clear. Any doubt in this thing, guys? So you see this can be cancelled out or you can cross multiply over here. So you will be left with only k into k minus 5, right? 8 can also be taken over here and that will be 0 only. So therefore the two values of k, they are possible. K is equal to 0 and 5. You got that logic? K is equal to 0 and 5 are the answers to this question. Any doubt in this question? Babuan, happy sign, Mahendra, Ajit, happy sign? Please comment in the chat quickly. So k is equal to 0 and 5 are the answers over here. Very good, happy sign. A simple question indeed. Any doubt in this question? Just comment that quickly, because if you will not let me know, how will I know that you are not getting it, right? Is it clear to everybody in this session? Okay, so let us move on to the next one. If one root of this polynomial, see, many a times root is also written, although technically for a polynomial you must say its zeros are there, but many a times I have seen in many books they write roots as well, they write zeros as well. No, product of roots if you will use, you will not get anything over here, right? I hope you got it, happy sign, because product of roots will be what? Product of roots will be minus 9 by 4. You got it? So it will make it more complex, happy sign. Although you can use product of roots as well, from there you can get the value of alpha, but it will make it more complex. I hope it is clear, happy sign. Now over here, this is the different type of question in which one root is reciprocal of the other. So one root is reciprocal. It means if one is alpha, the other is 1 by alpha. Whenever you get a question like this, it means that you have to take product of roots only. They will make questions like that. You have to find product of roots or zeros, whatever it is. So product of zeros is equal to c by a for a quadratic polynomial, right? So that is equal to, what is c? The constant over here, that is k. And what is a? A is the coefficient of x square, that is 5. So you see this will get cancelled out. So if you simplify, k will come out to be equal to 5. So therefore 5 is the answer. I hope it is clear. You got that logic, happy sign, that why we are not using sum of zeros over here. It will not help you in any way possible. It will make it more complex. There is no use of that. So therefore I had taken these two questions of if one zero is negative of the other and if one zero is reciprocal of the other. Exactly. So k is equal to 5 is the answer. I hope it is clear to every student. Let us do the next thing over here. If the zeros are in the ratio 3:2, then you have to find the value of k. So over here I am giving you a hint just that over here only one thing is not going to help. I mean only sum of zeros or only product of zeros will not help. You have to use both of the rules over here, both of the formulae over here. Ratio of roots are given, ratio of zeros are given. Then you have to find the value of k. So you see, when things are given in the ratio form, we can say that the zeros are something of this form or not. 3 alpha and 2 alpha. Can we say that? Because their ratio is given. You cannot say that these zeros are 3 and 2. Many students do that. It does not mean that these zeros are 3 and 2 because it is ratio. So it can be 6 by 4 as well, yes or no? It can be 12 by 8 as well. So you don't know what is the exact value of the 0. You cannot say it is 3 and 2. You have to take in the form of a common factor basically. So the common factor over here is alpha, you are saying. Now over here you have to use both the things. You have to use sum of zeros as well. Sum of the zeros will be 3 alpha plus 2 alpha. That is equal to minus b by a. So it is minus of b is the coefficient of x, that is minus k, and a is the coefficient of x square, that is 1 only. So over here if you simplify, you will get k is equal to 5 alpha, right? So k is equal to 5 alpha. So you must know the value of alpha as well. So for that what you will do? You will do the product of them. So 3 alpha into 2 alpha, the product of zeros will be c by a over here, right? And what is c? C is the constant term, that is 6 over here. And what is a? A is the coefficient of x square, that is 1 over here. So from here we can say that 6 alpha square is equal to 6 over here, right? So from here you will get alpha square is equal to 1. Now you see this is a quadratic equation in alpha. So you will get two values of alpha, right? Alpha will be equal to plus minus square root of 1, or you can say alpha is equal to plus minus 1. So alpha is equal to plus minus 1 means k will be equal to what? Alpha is plus minus 1, so k will be equal to plus minus 5. I hope it is clear. So k is equal to plus minus 5. Two answers are possible over here. Is it clear to everybody? Ajit, is it clear? Happy sign, violence is life, is it clear? To every student in this session, is it clear that k is equal to plus minus 5 is the answer? Any doubt in this session, in this question guys actually? Tell me quickly. You can also verify. If you will put k is equal to plus minus 5, then also you will get the ratio to be equal to 3:2 only. So it will be working actually, right? So no rule of mathematics is violated so that you can neglect any of the two values. Both the values are acceptable over here. Panda boy, we are over here for studies and you're talking about BF and GF. What is this? And please don't spam over there. Okay, let's move on to the next thing. Try doing this one guys. If alpha and beta are the zeros of this polynomial such that alpha minus beta is equal to 1, can you find the value of m over here? Please don't spam Panda boy, it's a request because people are studying over here. So you have to not disturb others. Okay. So over here alpha and beta are the zeros of this polynomial so that alpha minus beta is equal to 1. So you have to find the value of m. So before this I am asking a question from you. Wait. Before this I am asking a different question, although we'll do questions like that. Give me some seconds. Before that you can solve this one because it will make it complex. Before that you can find the answer to this question. If you have got this polynomial where alpha and beta are the roots or the zeros of this polynomial, you have to find 1 by alpha plus 1 by beta. I'm asking this over here, Ajit. Try doing this one. You have to find the value of 1 by alpha plus 1 by beta. It's okay, Panda boy. So basically see, they will for sure give you a polynomial for which you will not be able to find real zeros. They will for sure give you a polynomial like that of which you will not be able to find real zeros. You got that logic? So what you have to do, you have to manipulate this expression in the form of alpha plus beta and alpha beta. Because whenever they will give questions like this, they want you to use the relationship between zeros and coefficients of a polynomial. You cannot actually find alpha and beta and you cannot put those values over here. Maybe you will be able to do, but it will waste your time. Exactly. So for that we can take LCM of the denominators. It will be alpha beta, and in the numerator you will get alpha plus beta. Now you know what is alpha plus beta guys. Alpha plus beta is minus b by a, and what is alpha beta? It is c by a. So you see I can cancel out this, so it is coming out to be minus b by c over here. So what is b over here? From this polynomial, what is b? The coefficient of x, and what is a? That is also 1. So it is equal to minus 1 by 1. The answer is equal to minus 1. I hope it is clear to every student. Very good. That is the correct answer. Happy sign. Any doubt in this question guys? Tell me. So minus 1 is the correct answer over here. So other questions also you can do. Can you try doing this one? If alpha and beta are the zeros of this polynomial such that alpha plus 1 into beta plus 1 is equal to 0, can you find the value of c? So you just have to use more ratio questions. Happy sign, the questions were already pre-decided. I cannot change right now over here. I hope you understand that. So we have got other questions as well. Happy sign. Maybe if you will come in the next session, I'll take some more questions as well. No problem in that, right? So over here it is given that alpha plus 1, beta plus 1 is 0. So we can open the bracket over here. You'll get alpha beta plus alpha plus beta plus 1, that is equal to 0, right? If you will open the bracket over here, you'll get this only. Alpha beta plus beta plus 1 is equal to 0. Now you know what is alpha beta. Alpha beta is c by a, right? And what is alpha plus beta? It is minus b by a plus 1, that is equal to 0. Now see, the equation is in a different format, so you have to manipulate this equation first. So what I can do, just simplify it. This will give you x square minus, open up the bracket, minus px minus p minus c, that is, this is the polynomial, right? So therefore what is c? C is the constant term. So this whole thing is constant, right? So over here that is equal to minus p minus c. And what is a? A is the coefficient of x square, so that is 1 only. Plus minus b. So what is b? B is the coefficient of x, that is minus p. So minus p over here. And what is a? A is 1. And that is coming out to be equal to 0. I hope that is clear. So let's simplify this thing over here. So what will I get? Minus p minus c plus p, that is equal to 0 over here. So can I cancel out this, guys? So what I'm getting minus c is equal to 0, and if you further solve it, you'll get c is equal to 0. So that is the answer. I hope the question is clear to every student over here. Because it is not written in the standard form over here, happy sign. Standard form of a quadratic polynomial is this or not? Ax square plus bx plus c, right? So you see over here, this is not written in the standard form. So therefore you are opening the bracket to write it in the standard form. If you will compare, a over here is 1, b over here is minus p, and capital C over here is minus p minus c. You got that logic? Therefore we are doing that. Otherwise you will not be able to solve this question. I hope it is clear to you. Happy sign. Right or not? Okay. Okay, so can you try doing this question? If m and n are the zeros of this polynomial, can you find the value of m by n plus n by m? M by n plus n by m over here. So what I was saying, most probably they will give you a polynomial for which you will not be able to find real zeros. It will make it complex. So what you have to do, you have to manipulate this expression in the form of alpha plus beta and alpha beta. So if you take the LCM over here, what will I get, guys? I'll get mn in the denominator and I'll get m square plus n square in the numerator. Now you don't know the value of m and n separately, so you will not be able to find m square plus n square like that. So you have to manipulate this expression, m square plus n square, can I write like this? M plus n the whole square minus 2mn. Can we do like this, guys? Divided by mn. Because what is m plus n the whole square? Just do that in your mind. This is nothing but m square plus n square plus 2mn. So you are subtracting minus 2mn. So basically if you simplify this thing in the numerator, you will be getting m square plus n square only. You got it? Now you can easily put the values. Because what is the value of m plus n over here? Sum of the zeros over here, it is equal to minus b by a, correct? So it is equal to minus 11 by 3. And the product of the zeros over here, that is equal to c by a. So that will be equal to minus 4 by 3. You got that logic? So you can put the values, you'll get the answer over here. M plus n is minus 11 by 3. So just put the values minus 11 by 3 the whole square minus 2 into product of the zeros, that is minus 4 by 3. In the denominator as well, you'll be getting minus 4 by 3. So this is the answer. Any doubt in the question? Obviously the banana boy, we are not doing that over here. Exactly, very good, happy sign. We are doing that only. Banana boy, whatever we are doing, we have to work according to that only, na? I cannot pop up a different concept in between a session. I hope you understand the reason behind that. So this is basically 121 upon 9 plus 8 by 3 over here, and in the denominator you are getting minus 4 by 3. Just simplify it quickly, you'll get the answer. So you'll get 9 in the denominator, you'll get 121, and then you'll get 8 3s are 24, and in the denominator you are getting minus 4 by 3. So what you will be getting, guys, this is 145 by 9 into 3 by minus 4. So basically this is the answer. You can simplify it. Is it getting cancelled out? I think no. Okay, so this will be the answer, minus 145 upon 12. I hope that is clear to every student over here. Any doubt in the question, guys? I hope that is clear to every student. Exactly, that we are getting that only. I hope we are getting minus 145 upon 12 only, happy sign, right? I hope we are getting that only. Please check the calculation. Maybe I've done it correctly only, right? I don't remember the answer although. I hope that is clear. See what is happening over here, Vishnu. You cannot find the value of m square plus n square separately because you don't know the value of m and n. I hope you got it. And you will not be able to find the value of m and n separately because most probably they'll give you a quadratic polynomial which you will not be able to factorize. I hope it is clear. So what I am doing, I am manipulating this expression in the form of m plus n the whole square and mn. So m square plus n square can be written like this, m plus n the whole square minus 2mn. You can check it because this is m square plus n square plus 2mn and minus 2mn you are cancelling it out. So therefore this is nothing but m square plus n square only. Now you know the value of m plus n now, because for a quadratic polynomial sum of the zeros is minus b by a and product of zeros is c by a. Just put the values over here, you'll get the answer. Just simplify. I hope it is clear. Is it clear? Yes, happy shine, but I hope the question is clear, right? So see, one more question I did skip because it was not very simple. Therefore, I had taken some simple questions first. Now you have got this question. Can you do it, guys? Can you do it over here? You see, for this polynomial, alpha minus beta is 1. Difference of zeros is given to be 1. So you have to find the value of m over here. Difference of zeros is 1. So what I can do over here, can I square on both these sides of this equation? I can write it like this, alpha minus beta the whole square, that is equal to 1 square. See, I don't know the value of alpha and beta separately, so I cannot find the value of alpha minus beta. So I have to manipulate this expression in the form of alpha plus beta and alpha beta. I think no, happy sign. So I can write it like this or not, alpha plus beta the whole square minus 4 alpha beta. Tell me, if you simplify alpha plus beta the whole square minus 4 alpha beta, will you not get alpha minus beta the whole square? This identity you have studied in grade 7, in grade 8, in grade 9 as well. That x minus y the whole square can be written as x plus y the whole square minus 4 alpha beta. I hope that is clear. Now you know the value of alpha plus beta. Alpha plus beta is what? Minus b by a, correct? It is equal to minus b by a. So it is minus of b is the coefficient of x. So minus of minus 5, a is the coefficient of x square. So this is nothing but 5 over here. So you'll put 5 square minus 4 into alpha beta is what? The product of zeros. So the product of zeros is equal to c by a only, and that will be equal to m by 1, right? So that is equal to m only. This is equal to m. So just put m over here, and that is equal to 1. So you can simplify. So you'll get 4m is equal to 25 minus 1 is what? 24. So this is equal to 6. So the value of m is coming out to be 6. Is the question clear? Very good, dead official. Very good. Is the question clear to every student in this session? Banana boy, happy sign, Vishnu, dead official. Correct. M is equal to 6 is the answer. I hope it is clear to every student in this session. Right. So, one or two more basic questions we can do. So, try doing this one. Basic questions only on the basis of cubic polynomials. Can you find the product of the zeros of this cubic polynomial? This is the two questions are there basically. This is the first part and this is the second part. So, can you do the first part? Can you find the product of the zeros of that cubic polynomial over here, guys? Can you find the product of zeros? So if you have understood Vieta's formula, which I had explained in this class, you will be able to do this in seconds. Otherwise, you'll find it complex, right? Let's do that. So what did I explain? So for a cubic polynomial, 3 zeros can be there, alpha, beta and gamma. So what was the pattern? Take 1 0 at a time in the first place, 1 0 at a time. Alpha plus beta plus gamma is minus b by a, right? Now what will you do? You will take 2 zeros at a time, alpha, beta, beta, gamma, gamma, alpha, right? Now this was minus b by a, change the sign to plus c by a. You got it? So 1 0 at a time, 2 zeros at a time. Now you will take 3 zeros at a time, right? So this is plus c by a. So this will be minus d by a. Change the sign to minus d by a. So basically you have to find the product of zeros. So you see A, B, C, D. So D is equal to minus 6. Your answer will be minus 1 minus is already there in the formula itself. So minus of minus 6, and A is the coefficient of x cube, that is equal to 1 only. So the answer is coming out to be equal to 6. Option C is correct. Is it clear to every student? Very good. That is clear. Is it clear? Dead official, happy sign. Any doubt to other student? Babuan, the beast. I hope it is clear. Now what about the next question? Given that the two zeros of the cubic polynomial are 0, can you find the third zero? Tell me. Dead official, is it not clear to you? This I had explained in the first few minutes of this class. Okay, that is clear. Very good, dead official. Now see, two zeros of this cubic polynomial are 0, then the third zero you have to find. It's a direct question, guys. Can we not use this relation only? Two zeros are 0. Suppose I am saying that alpha is 0, beta is 0, gamma we have to find, and that is equal to minus b by a only. So I can say gamma is equal to minus b by a is the answer. It's a direct question. Any doubt in this session to any student in the class, tell me. Obviously, these were basic questions on the basis of relationship between zeros and coefficients of quadratic and cubic polynomials. But obviously, there is more to do. You have to practice many more questions to be very good at these things, right? So that's all we needed to discuss in this session. In the next session, we are going to do the formation of polynomials when sum of zeros and product of zeros, these things are given on the Infinity Learn class 9 and 10 YouTube channel, wherein we are conducting two series, Pratham series for grade 9 students and Pioneer series for grade 10 students. So stay tuned to the Infinity Learn class 9 and 10 YouTube channel. We'll meet in the next class. Bye bye guys. Take care everybody.